Okay, now let's discuss the applications of electrolysis. Electrolysis is a very important and useful process which has a wide range of applications. It's used in a large number of industrial manufacturing processes. So some of these are, as we discussed, the production of chemicals like caustic soda, kadong chloralkali nga process, and chlorine gas on a large scale. Production of non-metals such as hydrogen, fluorine, and chlorine. Electrometallurgy, or the method that uses electrical energy to produce metals by electrolysis. Electrolytic refining, or the process of removing the impurities of a metal by means of electrolysis. And electroplating, or the coating of a metal with another metal by electrolysis. So, electrometallurgy. This is the method of producing metals from their ores by means of electrolysis. So this method can be done in two ways. So the melting of the ore and electrolyzing it in the furnace. So an example of this is kadong preparation of sodium metal from molten sodium chloride. So electrometallurgy dito siya. Or treating the ore with a strong acid to obtain a salt, and the salt is electrolyzed to release the metal. So like an example ani is the Hall-Héroult process, which is used in the preparation of aluminum from bauxite. So this is kanisha, this is aluminum, so this is the bauxite ore. And imagine, so this metal comes from this ore, diba? So that can only be done by the use of electrolysis. And also in the preparation of magnesium from seawater. So gikan sa tubig, sa dagat, we'll be able to produce magnesium. So these are some of the applications of electrolysis. So this is the process of the preparation of aluminum. So you can watch this the process through the links here provided. So this was invented by Charles Hall, who started working on it in 1888, and by Paul Héroult, who independently discovered the process 2 months later. So what sila nagsabot? They just happened to come up with the same process. So the electrolytic cell used in this procedure is called the Hall-Héroult cell in honor of the two inventors. So first, bauxite, the ore, the most common source of aluminum, is made to undergo purification by reacting with hot sodium hydroxide, forming a soluble sodium aluminate. So si bauxite, gidugangan og sodium hydroxide. And then, the undissolved impurities of the ore are removed by filtration, and the filtrate is added with an acid which causes the precipitation of aluminum hydroxide. So, gikan sa bauxite, naa na kay ni precipitate nga aluminum hydroxide. And then, the aluminum hydroxide precipitate is removed by filtration and heated to produce alumina. So, ang aluminum hydroxide, solid naman siya precipitate, gihit siya para mo produce og alumina or aluminum oxide. So, gikan bauxite, padung sa aluminum hydroxide, and then nahimo na siyang aluminum oxide. So, hinay-hinay na produce ang aluminum. And then, the aluminum oxide is dissolved in a mixture of molten cryolite and calcium fluoride. And then, kani siya nga mixture, kay gidissolve naman siya. So, muna ni siya ang iyahang bali solvent niya. Gidissolve siya dito. The mixture is then made to undergo electrolysis, where the aluminum ions undergo reduction to produce aluminum metal at the cathode. And at the anode, ang na-produce kay oxygen, carbon monoxide, and carbon dioxide. So this is how aluminum is prepared. And again, you can watch the video of the process through these links. For magnesium, gikan sa water, so magnesium can be isolated in large quantities using electrolysis. The major source of magnesium is seawater, which contains approximately 0.5% magnesium chloride. So, gamay ra siya, no? So, what's done is calcium hydroxide is added to seawater to precipitate magnesium hydroxide. So, gikan sa seawater, mo-produce og magnesium hydroxide, and then this precipitate, this is solid, diba, precipitate, is added with hydrochloric acid, producing an aqueous solution of magnesium chloride. Mg aqueous man, Cl2 aqueous. And then, kay aqueous man siya, so the magnesium chloride nga pure, kay, diba, solvent is water, is just evaporated. Pure magnesium chloride is collected by evaporating the solution. So, ni-evaporate ng water, magnesium chloride na lang ang nahabilin. Ang magnesium chloride, gimelt siya, it's molten, and it's made to undergo electrolysis, producing liquid magnesium and chlorine gas. So, gikan sa seawater, mo-produce og magnesium. Another application of electrolysis is electrolytic refining. So, it's the purification of metals from their ores or compounds by means of electrolysis. So, an example of this is the electrolytic refining of copper. Impure copper from chemical reduction of copper ore is cast into large slabs that serve as the anodes for electrolytic cells. So, kintahay kani. This is the copper ore. So, ang copper ore kay gihimo siyang anode. So, cut into large slabs, not just like that. And then, the cells use thin sheets of ultra-pure copper as cathodes. So, kung kani siya ang ore, ang pikas, kay naay pure siya nga copper gyud. Okay? And then, the solution, the electrolyte used, also has a copper nga ion solution. So, here, it's an aqueous copper sulfate that's used as an electrolyte. So, nadyo'y copper tanan, diba? So, the impure copper slabs contain impurities which are also oxidized at the anode. By maintaining a low voltage supply, only copper is deposited at the cathode, which is made of pure metal copper sheet, and the ionic impurities remain in the solution. So, we can see here nga muna siya. Na ay anode mud, mga impurities, and then, so we also have other impurities here, but only copper will be deposited at the cathode. So, bale, ma-use up ni siya, magkaanam siya ka-use up ang katong anode, which is made of the impure copper nga ore, and then magkaanam to og kabaga tong thin sheet sa pure copper nga gihimo nga cathode. So, from this ore, mo-produce na siya og pure nga copper. And also, you can watch the video of the entire process through the link provided. And then, electroplating. It's the coating of one metal on the surface with another metal by means of electrolysis. So, in this case here, the object to be plated serves as the cathode, and the plating metal serves as the anode. So, they don't have to be the... So, unlike sa electrolytic refining, lahi-lahi sila nga mga metals, no? The electrolyte used usually contains a low concentration of the electroplating metal. Kung unsay metal nga i-coat, mao dapat ang naa sa solution. Alright? Then, the metals which are most commonly used in electroplating are gold, silver, copper, nickel, and chromium. So, unsay purpose? They protect metal from corrosion, they serve as decoration, they help in conduction of electricity, they reduce friction, and they even protect from radiation. So, this is another video here showing the electroplating process. Now, let's proceed to the quantitative aspect of electrolysis, so computation na tayo dapita. In electrolytic cells, one very important consideration is the amount of energy necessary for a given amount of material to react. And this amount of energy can be determined using Faraday's Law. So, according to him, Michael Faraday, the amount of electrical charge introduced to the non-spontaneous system is proportional to the chemical change produced, and that a quantity of electricity produces a corresponding amount of substance being electrolyzed. Mo input ka og electricity, na siya corresponding amount sa substance na ma-electrolyze. So, knowing the electrical charge needed to produce a certain amount of substance in a non-spontaneous redox reaction helps us determine the energy needed for the reaction. Kung kahibaw ta, kung pilay electrical charge needed para naat ko sa atong target nga amount sa substance nga produce, it would help us kung pila the energy needed para sa reaction. So, electric current is the rate of flow. So, the quantities that we use here is first electric current. So, it's the rate of flow of charge per unit time t in a circuit. In this case, it refers to the charge of electrons flowing. So, the formula for charge is Q equals I over T. The charge which flows, therefore, by passage of a constant current, this is baliktad. So, this is supposed to be I equals Q over T. And then, so the charge is Q equals IT. The electrons transferred during redox reaction can be used to derive the total amount of charge involved in the process. So in the half reaction, supposing this is the half reaction, then N electrons, mole electrons are transferred here. The charge transferred in the reaction can be computed using the formula. So charge is equal to the number of electrons transferred, mole electrons transferred, times F, which is the Faraday's constant, and that is equal to 96,480 coulombs per mole electron. So again, kaning mole electron, mo ni siyang number of electrons nga na-transfer diri. Okay? So this diagram shows the steps in finding the mass of the substance formed in the electrolytic reaction. So first, if you have the current, you can solve for Q. So once you have that, you can once you have Q, and then using you can find the number of moles of electrons using this, and then after finding the moles of electrons transferred, you can find the number of moles of substance oxidized or reduced, and after which, using the atomic mass or the molar mass of the substance, you can find the mass of the substance produced. And again, using this charge, you can solve for the energy. So energy, we will talk about that later. So kaning number of moles substance, magdepende siya sa atong redox reaction. So for example here, so in this reaction, 2 moles of electrons are transferred for every 1 mole of copper nga plated. 1 mole of electrons transferred for every 1 mole of silver. 3 mole electrons for every 1 mole of 1 mole of gold. So magdepende siya sa ato ang half reaction.